Okay, today we're looking at a new concept, velocity and acceleration as a rate of change. So far we've been looking at gradients, okay? And gradients are first derivatives. So we're going to look at velocity and acceleration as a rate of change. In other words, that velocity and acceleration as derivatives of other functions. Now, first, before we look at velocity and acceleration, we're going to look at displacement. Now, the displacement of a particle is the position of the particle relative to a fixed point O, and that's normally the origin. Okay, now displacement it's similar to distance, but it's a little bit different. Okay, so it may be positive or negative, depending on whether P is to the left or right of our fixed point O, and that fixed point is normally the origin. Okay, so unlike displacement, however, so I could have a displacement of -5, or I could have a displacement, for example, of +3. So, for example, I might have, here's the origin. If I'm here at 2, this is my displacement is x is 2, but if I'm over, say, here at -3, my displacement here is called x is -3. Normally, the pronoun we'll use for displacement is x, okay? So, for example, if I just say the displacement is x is 2, it means that you're on the right-hand side of the origin, and if I say displacement is -3 or x is -3, you would be on the left-hand side of the origin. However, if I say distance, that's always a positive quantity. I might say, how far did you travel? If you've traveled to the left 3, you say the distance traveled is 3, but the displacement, if I've traveled to the left, would be I'm now at x is -3, okay? So displacement and distance aren't always the same. Sometimes they're the same, often they're not, okay? So here's an example. A particle moves along a number line as follows. So it starts at x is 3. So I've got the origin here. It starts at x is 3, so it starts here. Starts here at x is 3. And then it moves to x is -2, which is down here. So it starts here, and then it goes to x is -2. And then it stops, and then it goes back to x is +1, which is here. So it starts here, it moves from x is 3 to x is -2, and then it moves to x is +1. So the distance travelled will be from 3 to -2. Now I can do it by jumps, or I can do it by subtracting. Okay, so I'm jumping 1, 2, 3, 4, 5. So it's travelled 5 units to the left. So this is what it's really done, 5 units to the left. And then it's gone from -2 up to 1, and then 3 units to the right. So therefore the distance travelled is 8 units. So I'm going 5 left and 3 right. It's 8 units, okay? So that's the distance travelled. So I could start here, walk 5 units to the left and 5 units back, and I've travelled 10, for example. So start here, 5 units left, 5 units back is 10 units that I've travelled. However, the displacement would be 0 because I've started and finished in the same spot. So here, the change in displacement, here I started at 3 and I ended up at 1, so my change in displacement, so change in my particle's position, is really only 2 units. So often we do change would be the final position minus the initial. So it would be 1 minus 3, which is -2, but the change in position is 2 units. So this -2 would mean that it's moved 2 units to the left from where it started. But I can just look at that there. I start at 3 and I finish at 1. My change in displacement is just that I have moved, 2 units to the left. So you can see how that's quite different to distance travelled. Like I said, you could start at a point walk around, 5 units to the left and 5 back, and your displacement is 0. Your change in position is 0, but you would have travelled 10. Okay, now that's displacement. We often use x for displacement. Now we're going to look at velocity. And remember, this is velocity and acceleration as a rate of change. Now, for example, velocity, it's the rate of change of displacement with respect to time. Now, velocity is very similar to speed, okay? So it's similar to speed. Velocity, however, has direction, and it can be negative or positive depending on which way you're traveling. Whereas with speed, you've only got positive quantities. You might say, okay, I'm walking 5 kilometers per hour, or I'm driving at 60 kilometers an hour, like 5 kilometers per hour walking, driving at 60 kilometers per hour. We can see that speed is just distance over time. Now, velocity is very similar. However, it's the rate of change of displacement with respect to time. So we know that speed, we can see here, it's distance over time. The thing is, with speed, you always have positive quantities. Okay, you can't travel at a negative speed, but with velocity, you can have positive or negative quantities, depending on whether you're traveling to the left or the right. So velocity is the rate of change of displacement with respect to time. Okay, so units of velocity, often we use meters per second. So you could write it m/seconds or ms to the -1, or you could have centimeters per second, so centimeters/s, or centimeters seconds to the -1. Again, as I said, velocity, and here we've got, sometimes you can have kilometers per hour as well, okay? So velocity can be negative or positive depending on the direction of travel, and sometimes also velocity can be 0. That means you're not moving. So if a particle is moving to the right, then the velocity is positive. Now, if a particle is moving to the left, the velocity is negative. Now, remember, you cannot travel at speeds below 0. So if you have a negative velocity, it just means that you're moving to the left, okay? And if a particle is not moving, or we say stationary or at rest, velocity is 0. Now, as we said, velocity is the rate of change of displacement with respect to time. So as a rate of change, okay, that is the change in displacement versus the change in time. So I might do an x versus t graph. It might look like this. Let's say it looks like that. The gradient of that curve, that, for example, is a straight line, but remember, you could have a curve like this, x versus t. The gradient would give me the rate of change of x with respect to t, and that is when we're talking, for example, if you're walking and you travel, say, 5 kilometers in an hour, your speed is 5 kilometers per hour. Or if you're driving and you travel 40 kilometers per hour in 1 hour, then your speed is 40 kilometers per hour, and that's often an average. So velocity is the change in displacement with time, and because not every curve is a straight line, it'll be the gradient of the x versus t graph, or the gradient of the displacement versus time graph. So it's you just have to learn this, that velocity is dx dt. Okay, now if my curve is quite steep, let's say my curve looks like this, and where the curve is quite steep, the particle will have a greater velocity because the gradient represents the velocity of the particle. So it'll be traveling faster, all right, or it'll have a greater velocity. If I have a curve that looks like this, my xt curve, actually, no, it can't really go. Oh, no, it can. Okay, where it's stationary, okay, it means that dx dt is 0, so the gradient is 0. Now we know that velocity is dx dt, so if the gradient of this curve is 0, it means that the particle dx dt is 0, or the velocity is 0. So where your curve is flat, you have zero velocity, or the particle's not moving, okay? And when the gradient of the curve is positive, like this, because velocity is the gradient of the curve, the particle is moving to the right, because as we said, if velocity is positive, particle moves to the right. And if the gradient of your curve is, say, negative, so for example, here the gradient is positive, particle's moving to the right. Here I might have a curve like this, that's x versus t, the gradient's negative, particle is moving to the left. Okay, now, okay, so remember, positive velocity, particle moving to the right. Negative velocity, particle moving to the left. Not that it's traveling at a negative speed, you cannot travel at negative speeds. Okay, so let's have a look at this example. A particle moves along a straight line for 8 seconds. So this is its displacement, and this is the time, and this is like 1, 2, 3, 4, 5, 6, 7, 8. Time is in seconds. And it starts at a fixed point S. So, or you could say it starts at, oh, that's the number 0. So this is position S. At time t is 0. And at time t seconds, p, the particle, is x. This is just x as a function of t, okay? Meters to the right of s. So first question here is at approximately what times is the particle moving to the right? Now, got to understand what moving to the right means. If you're moving, you're traveling to the right, you're going that way. In other words, you've got a positive velocity. But look, the other thing here, you can look at this, and this just gives you the position of the particle at any particular time. So at time 0, you're at the origin. But at time 1 second, you're 1 meter to the right. So this, let's say you started here, you've moved 1 meter to the right. So I can actually show all of this on the number line. And then from 1 to 2 seconds, looks like you've moved back to the origin. So you've gone back this way. So first we were traveling to the right, now we're traveling back to the left. And then from 2 to 5 seconds, you've traveled, you're at the origin, and then at the 3 second mark, you look like you're about at -2, and at the 4 second mark, you might be at about -4. Remember, I've made these up. And at the 5 second mark, you're at -5. So from 0 to, from the 2 second mark to the 5 second marks, you're still traveling to the left. And then I'm here at -5, but then by the time I get back to 8 seconds, it looks like I've moved from -5 back to about -1, so I've traveled back here. So I can see I'm traveling to the right here, I'm traveling to the left, and then I'm traveling to the right. Now, instead of doing it this way, I look at the gradient of my x versus t graph. Remember, this is velocity as a rate of change. So velocity is dx dt. Now dx dt is the gradient of the curve. And if velocity is positive, you're moving to the right. Now how do we know what velocity is? It's the gradient of this curve. So where is the gradient positive? From 0 to 1, and from positive velocity, positive gradient from 5 to 8 seconds. So it's between 0 to 1 second and 5 to 8 seconds. So that's when we've got positive velocity, we're moving to the right. So negative velocity is when v is less than 0. In other words, the gradient is less than 0. So this one up here, dx dt, was greater than 0. So this is when the gradient of the x versus t curve is negative. Be careful. This is negative, so I'm going to put little pluses and negatives at plus, this looks like 0. Then I've got all these negative gradients. Then I've got a 0 gradient down here, and then I've got positive gradients. So where the gradient is negative, you're traveling to the left, and that is from 1 to 5 seconds. That's when I'm traveling to the left. Where the gradient of this curve, remember velocity is the gradient of the x displacement versus time curve. So I've got negative velocity from 1 to 5 seconds. Now then it says at approximately what times is the velocity of the particle equal to 0. Velocity equals 0 means that dx dt, the gradient of the x versus t curve, is 0. It means the particle is not moving. It's at rest. And it's when the gradient of the curve is 0. So that's at time 1 second. We can see the gradient 0, and at time 5 seconds. So it's time equals 1 and time equals 5 seconds. And also it says at approximately what time is the particle moving with the greatest velocity. Now, as we said on the page before, the steeper the curve, so when the curve gets really, really steep, your gradient, it's when the gradient is the largest value. When the gradient is, let's say, the steepest, okay, that's when you are moving with the greatest velocity, because remember, velocity is the gradient of the curve. So wherever you've got the biggest gradient, now it doesn't have to be in the positive direction. So if I look at my slope, that's fairly flat, and this is very steep here, but the gradient is negative, so I'm moving very quickly towards the left. Okay, and if I was to pick where I have the steepest curve, it would be about time is 3, because then it flattens off again. So the particle is moving with the greatest velocity at time equals 3 seconds, and it's moving to the left because velocity is negative there. But the particle, it depends whether you think this is steeper or this is steeper. Look, it's fairly steep here as well. Okay, it's also moving very fast at time equals 8 seconds. So it depends which one's steeper. Okay, if we think that this is steeper here, then this would be the greatest velocity. But if we think that this is steeper here, then this would be the greatest velocity. It may be slightly steeper there. I'd have to measure them. Okay. Now it says to describe the motion of the particle. Now to describe the motion of the particle, what we did up here was quite good. We started at the origin and then we moved to the right for 1 second. We don't say where we finished because I've made these imaginary values here. And then we've taken after another second, it looks like we've turned around and we've moved back towards the origin, and we've reached the origin again at 1 second, after another second. So you would say something like you start at the origin, you move to the right for 1 second, and then turn back and move to the left for 1 second, and to return back to the origin. Okay, so that's what's happened so far. You start at the origin, you move to the right for 1 second, and then you turn around or turn around, and move to the left for 1 second and return back to the origin at that time. So if that's describing this bit here. You move to the right for 1 second, and then you're moving back to the left, back to the origin for 1 second. Because if you've gone to the right of the origin, you've got to come back. If you're going to get back to the origin, you've got to come back to the left. Then it looks like you speed up. You then continue traveling to the left for another 3 seconds. So then you continue. I'd say you then speed up and continue traveling to the left for 3 seconds. You then stop at the 5 second mark. Actually, you speed up for 1 second, then you slow down. Continue traveling to the left. So what you've really done, you're still traveling to the left, you sort of speed up for 1 second up to the 3 second mark, and you're still traveling to the left, but you're slowing down now, and then you stop at the 5 second mark, okay? So you stop at 5 second mark, and then you turn around again, and then you travel for another 3 seconds, heading to the right. Okay, so that's a description of the motion. Okay, so whenever your velocity is negative, you're traveling to the left. Whenever it's steep, you're going fastest. Whenever it's flatter, you're slowing down. Whenever the gradient is horizontal, you've stopped. So here we've stopped there. Here we've stopped here. Okay, and here the gradient's positive, so you're traveling to the right again. Okay. Okay, now here is our next page. So the graph shows the displacement of a particle. Remember, displacement is x. That is moving in a horizontal line. So have a look at the velocity. It's positive. And then at the 2-second mark, or minute mark, sorry, the velocity is 0, or the gradient 0. So we've got positive velocity here. And then we've got 0 velocity there. Then we've got negative velocity. Now remember what that all means if you're moving to the right and if you're moving to the left. Okay, so when you describe the motion of the particle, you want to say where you started, where you traveled, how long you traveled for, and things like that. So it looks like you start at, now this is at x is 5, but that's 5, it does have the units, so 5 meters to the right of the origin. You then travel right as well, because if you're starting at x is 5, if I draw it on the number line, here's my origin. I start at 5, and then I'm traveling, just trying to see what this value is here. I think it's 9. So I go from 5 to 9. So I start at x is 5. And then I take 2 seconds. After 2 seconds, I'm at, pretty sure that's 9. So I then go to x is 9. So I start at 5 meters to the right of the origin. I travel right for 2 seconds until you are 9 meters. So you travel right, I suppose, for 4 meters, for 2 seconds until you are 9 meters to the right of the origin. Okay, you then, velocity's 0, so you then stop and you turn around and travel to the left because my velocity now is negative. Now, after another 3 seconds, you are back at the origin. So if you look at the 5-second mark, you're back at x, so you're at the origin. I wouldn't put back at the origin. So after another 3 seconds, you are at the origin. So in the first 2 seconds, you went from 5 to 9, and then you turned around. And then from 9 to x is 0, you took another 3 seconds to get to x is 0. So that was that next bit there. But then you kept traveling left, and after another 2 seconds, you're, I don't know, that's about 16. X is negative 16. So then in another 2 seconds, you ended up at x is negative 16. Okay, so you've basically traveled, you've started at x is 5 units to the right of the origin, you've moved at 4 meters to the right, and that took you 2 seconds, and then you stopped and you turned around, and then you traveled to the left, and it took you another 3 seconds to get back to the origin, and then it took you another 2 seconds to end up 16 meters left to the origin. So you turn around, so I've just got that here, start at 5 meters to the right of the origin, travel right for 4 meters for 2 seconds until you're 9 meters to the right of the origin, you then stop, turn around and travel left, travel to the left. After another 3 seconds, you are at the origin for another 2 seconds till you are 16 meters to the left of the origin. And it appears that you are speeding up, traveling to the left. So you can see that you're speeding up, because you're actually traveling a longer distance in a shorter time, and also the gradient of the curve is getting steeper. Okay? Okay, now to graph the velocity of the particle as a function of time. We really haven't done many of these yet. We did sort of touch on it last lesson just for a bit, but we are going to spend more time on it. But what you've got to do, instead of here I've got displacement versus time, we now have velocity versus time, and we put our we need to know where the velocity is zero. So remember, we put some pluses. We've got positive velocity because the gradient's positive. Then we've got zero velocity, and then we've got negative velocity, okay? So it appears to be a bit steeper here, and then it's flattening, and then you've got zero. So at 2 seconds, I know that I've stopped. So velocity is zero after 2 seconds. So I come down to my graph here, and I say at 2 seconds, I've stopped. But I know in my first 2 seconds that the velocity is positive. So I know that I've got positive values for velocity here, okay? So it's going to start up here and it's going to go down there, but we're not exactly sure of the shape of the curve, okay? And then after 2 seconds, my velocity is negative, and I've got small values, and then I've got bigger values, bigger negative values. So I know that my velocity is negative afterwards, sorry. Okay, and it would look something like this. Okay? Okay, and that's up to 8 seconds. Okay? So it would look something like that. As long as you've got some positive velocity up here, then you've got zero velocity, because that's a zero value for velocity. And then after 2 seconds, all my velocities are negative because my gradient's negative. Okay, now we're going to be doing more of that sketching later on. So just completing this little table here. So stationary point is when you're at rest, you're not moving. Okay, now we're going to do more on this later. Okay, now if you've got a stationary point, then this here is called my gradient function. The graph of the velocity is the gradient of the displacement function, okay? So the gradient function is the velocity, which is dx dt. Now, if I've got a stationary point, or I've stopped moving, I'm velocity equals zero. So on my velocity versus time graph, I've got velocity at that particular time is zero. Okay, now, if my graph increases, up here it's getting, if my the graph increases, remember I've got a positive gradient. So feature of the gradient function, I've got a positive gradient. In other words, velocity is positive. I have positive velocity values for velocity. So if I've got v here, and these are positive numbers up here, okay? Now, if I've got negative velocity, so if my gradient function, which is my velocity function, lies below the horizontal axis, I've got negative velocity. That means that my graph, if we see what these values correspond to, that means my graph is decreasing. So graph decreases. So this, for feature of the function, this is my x versus t graph here. X versus t. Okay? So if I've got if I just draw like this, for example, stationary point, okay, means I'm not moving. If my graph is increasing, it means I've got a positive gradient. If my graph is decreasing, it means I've got a negative gradient, so the velocity is negative. So my velocity graph lies below the x-axis. Okay, if there's a stationary point on the gradient function, we really haven't seen anything like that, so we're just going to leave that one. If my original function cuts through an x-intercept, it just means that I'm at the origin, okay? There's nothing really on the gradient function that lets me know that, okay? But if there is an x-intercept on my velocity function, it means that my velocity is zero. Okay, so it means that the velocity is zero. So I have a turning point, you could say. I have a turning point or a stationary point on my graph. Okay, look, we're going to be looking more at this later, all right?